Okay, so back to this example. I hope you guys were able to show or verify this identity. So we start with the left hand side, which looks a little more complicated than the right hand side. So again, we can do it by converting everything into sine and cosine. Now, we don't see sine cosine on the left side or on the right hand side, but because we have less used to secant, but we see tangent. So tangent, this is kind of encouraging us to change everything to sine and cosine. So we have secant x, which I will write as 1 over cosine x. The secant x, which will be written as 1 over sine x. Parentheses, tangent will be sine x over cosine x, and the cotangent will be cosine x over sine x, which is equal to, I'm going to put a line in between here because the other one we will do it on this right hand side. So now I'm going to distribute. So when I distribute, I'll get 1 over cosine squared x. I hope you guys can see that, plus 1 over sine squared x. Okay. Now, if you look at the right hand side here, when you relate it, then you see this 1 over cosine square x is secant square x, and 1 over sine square x is secant square x. Now, why didn't we go do the common denominator? Well, if I do the common denominator, it will not give me this form. But try to see that we get that form. Now, what is the difference between these two? There is a plus sign in between here, where there is no plus sign, which means these are being multiplied. Looks kind of strange. We usually in algebra we don't see things like this. If this happens, this will be a very, very special case, like 2 plus 2 is equal to 2 into 2. What other numbers do give you that? I don't think there are other numbers that will give you that type of equation. So this is kind of strange. In trigonometry, we are seeing that this is going to be true for any real number you think about. Okay. So this was the right hand side that we wanted to show, and we are done. Now on the right hand side here, I take the next one, which is I'm going to show now that this, let's show that secant square x plus cosecant square x equals secant square x times cosecant square x. Again, I will start with the left hand side. So what can I do with this? How can I show that this converts to multiplication? I cannot directly do that. So let's try to convert it back to cosine and sine. And try to take the common denominator, which in this case will be from the numerator we get, what is sine square x plus cosine square x? That is 1. can write it as so 1 over cosine square is secant square, and 1 over sine square is cosecant square. So what we have shown. So this is how we work with this verifying the identity. So note here, I didn't do, like, I did not subtract something from both sides, did not divide both sides by something, or did not add some quantity to both sides. We work with one side at one time, and we can use any identities that we have in order to make our things simple, and that's how it goes. Okay, I would again like you guys to work with this next one. Both sides look complicated here. I don't know, maybe you can start with the right hand side first, because from the left hand side it's kind of hard to see how you will get this into that form. It seems kind of odd. But from the right hand side we might be able to see that if we convert things into sine and cosine, maybe it will come handy. So let's see, right hand side, secant of t minus tangent of t whole square. So I'll keep it in this form for now, and then later on change it into sine and cosine. So I get secant square t, I'm expanding this quadratic, minus 2 times secant t into tangent t plus tangent square t. I can now write it as 1 over cosine square t minus 2 times 1 over cosine t into sine t over cosine t plus sine square t over cosine square t. Okay. So you see at the bottom, we should be able to see that at the bottom each denominator is cosine square t. So we have on the top 2 sine t over cosine square t, and then sine square t over cosine square t. This is equal to, now the denominator is the same. So on the top, 1 minus 2 sine t plus sine square t. Now if you can see that this quantity is the square of 1 minus sine t. And at the bottom we have cosine square t, which can be written as, so because remember we want to get it to look like what we have on the left hand side. So on the top we can see that we got the 1 minus sine t, but how will we get rid of the square? So if you recall from the Pythagorean identity, sine square x plus cosine square x is equal to 1. Cosine square x can be written as 1 minus sine square x. So here cosine square t can be written as 1 minus sine square t. So now the bottom can be factored. The top is 1 minus sine t into 1 minus sine t. And the bottom is 1 minus sine t into 1 plus sine t. So the 1 minus sine t cancels out, and we get which is what we had on the left hand side. Move this over here. Okay, I would like for you guys to work with the other, starting from the other side. Show how can we get to the right hand side. So starting at the left hand side, the key is, hint is multiply top and bottom by 1 minus sine t. This is something I mentioned earlier in the basic principle of simplifying the expressions, that you, whenever you see a factor of 1 plus sine t or 1 minus sine t or 1 plus cosine t or 1 minus sine t, we multiply by the conjugate. So here this is what we have. To start by multiplying by 1 plus sine t, 1 minus sine t and 1 minus sine t. So multiply and try to simplify and see if you can get to the right hand side.